Hi there. I'm Chris Gear, and I am a middle school math and science teacher. And we're going to talk about taking a look at this graph. And so this graph is here because we're trying to answer a question that's been posed to us, and that is it possible that more than 50% of classes of 32 students contain at least one pair of students who share a birthday? And this is a great question. I actually remember this question from when I was in middle school, and my middle school math teacher, Mr. Saunders, helped us work through this in class. And it's an interesting question because it seems like that can't be possible, right? It's very counterintuitive. And so there's a few ways to get an answer to this question. We're going to try to use this bar graph and see if that'll help us get an answer to this question. And so looking down here, we have a graph, and the title of the graph is The Chances of Two People in Different Size Groups Sharing a Birthday. And so that sounds like that might help us out. I'm going to look down here at the bottom at the x-axis, and I see the x-axis is group size. And so we've got a bar graph, which means we're comparing things, comparing different groups and what's happening to them at the same time. And so I see that the person who created this graph has done group sizes by tens. And we're starting out actually with a group of one. It's impossible to have two people with the same birthday in a group of one. So we're going to move on. And then we have 10 and 20 and 30 and 40 and 50. And the person who created the graph stopped at 50. And I'm going to guess it's because the bar is almost all the way to the top. And that brings us to the y-axis. And so on the y-axis, we're looking at probability. And probability is the same thing as chances or odds. And the unit here is in percent. So that kind of makes sense because we're talking about 50% of the class. What are the odds? That more than 50% of classes of 32 students contain at least two people who share a birthday. And so what is the probability that that's going to happen based on the different size groups? And we're looking actually for a group of 32 students. And so when you use a bar graph, you can't always estimate really easily. It's not kind of like a line graph where you can find that point for 32 on the line and estimate where it might be. But in this case, we just need to know, hey, if it's higher than 50% for 10 or 20 or 30 groups of 10 or 20 or 30, then it's for sure higher than that for groups of 32. And this is really just a yes or no question, right? So I'm going to go and look at the group of 30. So that's pretty close to 32. It's a little bit below. So if it's good for 32, it's certainly going to be good for if it's good for a group of 30, it's certainly going to be good for a group of 32. And so I'm going to go up and find where the group of 30 lands. And it looks like it is well above 50% chance. And in fact, it looks like it's pretty close to about 70% chance. So the answer to our question, is it possible that more than 50% of classes of 32 students contain two students who share a birthday? We're going to say yes. That is definitely a possibility. In fact, it's higher than 50%. It's almost probably right around 70%. And so this data, again, doesn't necessarily feel like it makes sense to me. And so as a mathematician or scientist, I might think about what I might do with this information. One of the things that I could do is think about, does this connect with my own experiences in my own life? And when I think about it, I actually do know someone else who has the same birthday as I do, different year, but same date. They're a friend from the neighborhood where I've lived for a long time. And then I remember when I was in middle school and high school, two of my best friends had the same birthday. And my son and his uncle also share a birthday. And so now I'm kind of thinking, well, maybe it's a little more common than it feels like it should be. And so there's a couple of ways we could go about verifying this. Might just gather some more data. Let's try this out. I might pick, 10 classrooms in school and just go down the hall and poke my head in and say, hey, do you share a birthday? Which might take a little bit of time because you got to go through 32 people and their birthdays and see if they match. But you could collect that data and see if it starts to kind of match what's in this graph. It may not be exactly the same because we're talking about probability, but it might be kind of close. The other way to think about it is, can I prove it with math? Can I use a mathematical calculation to make an explanation for why this happens? So those are things that I would think about as a math and science teacher. And I'll leave that opportunity to kind of dig into this data up to you and your math or science teacher. But that is how I would use this data on this graph to answer this question.